Hello, everybody. Today we're going to do something a little bit different. I use computers attached to my telescopes when I'm doing my astrophotography. Previously, the Primalucci Eagle, which I'll talk about a little bit later on. Today, though, I'm going to use a clean install of an Intel N.I.N.A computer, which actually the Primalucci Eagles use. Certainly the versions that I've got. A clean install of Windows 10, and we're going to start installing everything that you need and setting up everything you need, or everything that I need to do image session. I've got a new telescope rig. I thought this time I will use a Pegasus Ultimate Power Box and an Intel N.I.N.A rather than actually buying a new Eagle computer for it. And so I'm going to get started, and hopefully by the end of this we'll have everything on the N.I.N.A all ready to go, so that at least we can go out, start calibrating things, and use it for this winter to capture some objects. Okay, let's get started. Now, as I said, we're going to install a few pieces of software on here, and we've got to kind of do it in order. We've got to start off with putting the ASCOM system in. We may need to put in some net drivers from Microsoft, and then we're going to go on to Sequence Generator Pro, put that in, register it, and then PhD2, Stellarium I want to put in, maybe a couple of other pieces of software as we go along, to be able to get a complete system sorted for astrophotography. Now, I use a very few pieces of software really. My main software is usually Sequence Generator Pro, especially for my main telescope that I'm using at any time. If I'm using a double rig, in other words, I've got two telescopes connected to the rig at the same time, then quite often I would use N.I.N.A to control any secondary cameras. Let's carry on, and I'll explain a little bit as we go along about my rig as well. So that, or rigs, because I've got a few, but this N.I.N.A computer, and I'll show you that now. This N.I.N.A computer, which I've got here, I'm running remote desktop at the moment to be able to use this, which is what I'll be using at the time with an Ethernet cable when I've got it attached to the computer, the telescope. As you can see, it's a Windows 10 Pro system here. It's not a terribly powerful PC, but it is an Intel i5, so it's going to be good enough, certainly. If I close this a minute, you can see it's a completely blank Windows that I've got here at the moment. I haven't really put in, well, I haven't put any software on it yet, so it'll be you'll be able to follow along completely and hopefully copy everything that I do. Now, the normal telescope setup that I would have would be something like this. Let's bring it in a little bit closer so you can see. This is N.I.N.A. This is my 152mm refractor. Gives you an idea. This is on my astrophysics mount. We've got the camera and everything at the back here, the focus motor down here. On top of the telescope, you'll notice this thing here with the red light. Now, if we zoom in on that a little bit, this is actually a Windows 10 computer. This is the Primalucci Eagle Observatory. And I've got two of these, and I tend to switch them on and put them onto the different rigs as I'm using them. I have got a couple of wide field rigs, especially ones that I want to take away to the Cornwall Astronomy Society, or just away in general to do some field work rather than working from home, and that's where I'll be using this this N.I.N.A computer. Now, Primalucci Observatory computer is basically just a Windows 10 computer with a power switching unit in. If we go here and have a quick look at it, you can see that it's got many ports. We've got ports for dew heaters, we've got the power ports here. They do have strange connectors on the Primalucci stuff. They're very, very good connectors, very, very expensive, unfortunately. We've got USB ports. Okay, so we've got a complete USB hub here. We've got wireless connectivity inside. It's got memory, hard drive, normal processor that you would have. A couple more ports over the other side. Very important for me is an Ethernet port. So I tend to, instead of using the Wi-Fi here, I tend to use the Ethernet ports an awful lot more. And for setting up, you can put on a monitor onto these, a keyboard, etc., just to set up. Little power button here and a reset button. It's a fairly simple setup, but it works very effectively. And I know a lot of people who've got mini computers just like this, or any fanless computer controlling their astrophotography equipment. Even things like the ASI is a very cut down version of something like this. The problem with this is it's very, very expensive. I paid about £1,900 for each of mine a few years ago. They've served me very, very well. But inside here, this section here is actually a N.I.N.A, Intel N.I.N.A computer, and this side here is the power distribution center, and it's got a USB hub built in, basically exactly the same as a power box of some kind. Here we can have a look. This is what the Intel N.I.N.A looks like when it's inside its normal case. Like I said, I've just got an i5 processor. 8 GB of RAM is going to be more than enough. The 120 GB SSD hard drive is a little bit small. If I was saving my images to it, then it would be a little bit too small, but I'm not. I plan to pick off my images as they're being created and put them on my Dropbox, as it so happens. Now, it does state that it runs between 18 volts and 19 volts, but it does work actually on 12 volts, especially as we're not using it for taking any power stuff off. Instead, we're going to add to that my Pegasus Ultimate Power Box. Now this, just like in the Primalucci thing here, as I said here, this side here is the N.I.N.A, this side here is the power box. Here we've got 4 12-volt outputs, which are switchable. Now these use a much more standard 5.5 connector, which is good. We've got a couple of dew heaters. It's one less than the Primalucci, but we only actually need 2, or I only ever really use 2. There's our input, power input there. It's also got 4 USB 2 ports and 2 USB 3.1 ports. It's got a stepper motor controller for a focuser. Nowadays, most of the focusers and the one on my rig are controlled by USB, so I'll be doing it just through the USB, but you have got a stepper motor controller if needed. In fact, I have got one telescope downstairs. It's a very large Newtonian, and that one has got an old Pegasus focuser and focus box, I think it's called, and it does connect straight into the stepper motor controller, which is nice. And it's a 12-volt power requirement. Now, one of these power ports can be left on all the time, and that way when you put power to the Pegasus Ultimate Power Box, you can plug that straight into the Intel N.I.N.A and it will switch on the computer at the same time. So with this, we'll put power up to the power box, and then that'll go down to the mount, then be distributed to the cameras, to the computer, and everything else that we'll need. So if we go on to the remote computer itself, let's get started with installing some of this software. As you can see, I haven't activated Windows yet. I'll do that after the video, but everything else we'll keep as is, and we'll just install the software. So let's go. Right, the first thing we're going to do, let's start off our Microsoft Edge, and I'm going to type in here ASCOM. Download. This is going to be for the drivers for everything that we'll need on our equipment. So, Download Center, ASCOM standards. Here it is, platform 6.6, update number 2, SP2. So let's download it first of all. And it doesn't take long. It's not a huge program. This is literally just drivers for lots of pieces of software, all done in one development package. Now, because it's done this way, it does make it nice and easy for us to be able to connect to lots of different tools very, very quickly without downloading lots and lots of different drivers all over the place. Now, we have got some specialist drivers that we're going to also pick up as part of the mount and the camera, but it'll be ASCOM that will control them. So let's open this file. Do we want it opened? Yes. Do we want the app to make changes? Yes. And here we go. Let's install it. Now, this quite often will need the net update, I think. Required, yes, the net framework. So this is a Microsoft product, so we'll just go yes. Let it do everything itself. This will take a little while, so I'll come back as soon as it's done. And now it comes up with the ASCOM platform installer. So net has been installed, so let's install this. This is the main ASCOM software. The net package that we just installed, by the way, is for programmers to be able to use it. It's basically an interface between the program that a programmer will write and Windows itself. It saves us having to program up the drawing of each one of the windows to read the inputs on the computer, to be able to pick up all the keys, etc. We don't have to do any of that. We can use the net protocol to be able to, or net procedures, to be able to pick up everything from Windows, draw anything on Windows, much easier. So programmers tend to use these libraries an awful lot. So once you've got the net program installed, you'll probably find in the background there'll be lots of other programs that will be using it. You just won't be aware of it. Most Windows 10 computers, when you're installing bits of software, at some stage or another will have the net system installed on it. Sometimes automatically, sometimes like this, with a fresh install, we've had to download it. The ASCOM platform 6.6 SP2 has now been installed successfully. On your old systems, or every now and then, just double check that the platform is up to date with the platform on this website. The website is ascomstandards.org. Just to make sure that you're up to date with all your drivers and the ASCOM itself. So finish. And that's done. ASCOM's now installed, so we need to go through the drivers and see which drivers we're going to use for our particular software. Now, if we go on to here, the first one I'm starting off with is camera, and camera is a difficult one because actually I'm using a Starlight Express here. So I need to go to an external site to be able to do this. So let's bring up a new tab. It's going into GitHub here. Install this ASCOM installer just on the side. Each set of drivers will be different. We're protecting the PC, will run anyway. This is because it actually needs to link into Windows itself. I accept the agreement. Okay, now it's asking what type of cameras. So I've got a color camera, so we'll start off with that one. Color camera is the 694C, and that's what we're going to be using for our setup at the moment. Does the main camera have a guide camera attached to it? No. I'm also going to add in a guide camera, in this case the Lodestar guide camera. Have I got any more? Yes, I've also got mono cameras. I've got a few of these Starlight Express cameras, H814, and we will no guide camera attached to that. I have no remaining cameras, and install, and it'll install those particular cameras that I've said. So close that, close that. We don't need this anymore. The next driver we'll need is filter wheels. Now I've got a filter wheel on it, but I think the Starlight Express drivers we just downloaded will deal with that. So let's have a look at a focuser. We're going to be using the Pegasus focuser here. So Pegasus Astro dual motor from, I think that'll be the one. So again, visit site. So drivers of the Pegasus contains the ASCOM driver. So let's open this in a new tab. Have a little look. Support for older products. Ultimate Power Box version 1. That's my one. So software. ASCOM switch driver. I'll also need the power box setup probably. So I think we'll start off with this one. There, and we'll also have the switch driver here. Okay. Ultimate Power Box focus driver. I may as well do that at the same time because I have got a focuser on a different telescope. So we'll start off with the power box, Ultimate Power Box install. Let's do that one first. Whereabouts I like it to be put. Do I agree with it? Yes. Install. Going to be lots of this little installations here, and there we go. That looks nice. We'll now close that because we don't want to use it quite yet. So that's the install there. The next one we want is the switch. I'm not 100% sure whether we need that, but we'll put it. Oh, this is the ASCOM switch, so yes, we will need it. Let's do that. I accept the agreement and install. We don't need the readme, that's absolutely fine. If you install one of these drivers that you don't use at the moment, it doesn't matter. Okay, so better to install more than less. On my Prima Luce Eagles, for instance, I've got drivers for lots of different setups on there. Some of them I will use, some of them I won't use, but they're there just in case. We're not using rotators, safety monitors, switch outlets. Let's have a look on this because the Pegasus Power Box does use a switch, and we've already downloaded that, so that's absolutely fine. Oops, gone back too far. So telescope mount, very important. So I'm using an Astrophysics go-to, so let's visit that page. We've got an FTDI driver. I'll need that straight away. That's the driver between the USB and the go-to. Now actually required for CP4 and CP5. Well, I'm actually using CP3, but I'm still going to install it. If it doesn't use it, then that's absolutely fine. But I'd rather have it on here at this stage rather than when I'm out with a telescope wanting to calibrate it. So that's that in. ASCOM driver, AP version 2. So latest release, history of changes. This is the setup for it. The version 2 drive is what I want to use. That will control my GTO CP3, which is the main controller on my mount. Now for every drive that you put on, quite often you have to read and mess around a little bit to pick things up. So what things do I want? Not really a lot, to be honest with you. Focus, I'm not using the astrophysics focuser. I'm just going to do that. Next, install, and done. Don't need to do the readme. So that's that one done. So we're getting there now. So we can close some of these windows. Go back to the ASCOM. Is there anything else we need? Plugins? No, we don't need any of this. None of this. There's the net platform. No. So that's ASCOM done and dusted on our system. We can close. There you go. That's ASCOM installed. If we go into here, we can see the ASCOM 6 platform. And there's all our things. We've got some simulators here so we can start testing some things. There's our astrophysics driver that we put into here. There's that's a polar finder, yeah. So it started. So the next thing is Sequence Generator Pro. So I'm going to go into here. If we go Sequence Generator Pro, that's what we're after. In here, accept all cookies. I will first of all download it. So we'll download the latest version. Download this. Open the file. And set up, yes. Accept the agreement and let it download. We'll create a desktop shortcut and install. Won't take long. And we'll install that. We'll launch that later. So finish that. We have now installed ASCOM and Sequence Generator Pro, so we're getting there. The next thing we're going to install while we're at it is PhD2. So PhD2, this is our auto guiding software. So we're going to download that. PhD2. Now this is from openphdguiding.org. We want the latest one, as always. Multi-star guiding works exceptionally well. There's a couple of other guiders out, but nothing seems to work as well as PhD2. So you can use this with N.I.N.A, with SGPro, with lots of other pieces of software. So always worth putting on here and making sure it's up to date. So install that, PhD2, install. We don't need to view the README, and we're not launching after installation at the moment. That looks like it. Okay. The other one I want to do is plate solve. PlanWave, they make mounts, by the way, and software. This is for plate solving our images. Once we've captured an image, plate solve it, and then we know exactly where we're looking at. So That's all right. We'll download PlateSolve 2. Now this one can take a little while. We'll open up the zip file, and we've got to extract everything really. Extract all. We want to find a nice place for this to go, so we're going to go into Documents folder. In here we're going to create a new folder here and PlateSolve 2. I'm going to extract it all to that. This is like a little driver. It's got the version number at the end of it. So inside PlateSolve 2, there we go. We've got our drive. These are Windows drivers here and the PlateSolve 2 software. So we've got that. That's good. Now we want to download the star catalogues. Let's go into here, find our downloads, APM catalogue. Now this is obviously a large file. It's got all the plates with all the stars in that it needs to search through. This is really just a large database. So Starry Ridge, yeah, next. Install, and again this will take a little bit of time, so I'll just speed it up a second for you. Click on finish. So two different catalogues, they do work slightly differently. One of them, I can't remember which one, is better for wide field. Another one is better for when you've got a larger telescope looking in. But we'll download both of them. It's useful to have a few of these catalogues installed, and you'll see why a little bit later. You'll also see that there's a speed difference with using different catalogues as well. So when you click on an image and ask it to PlateSolve later on, you'll understand why it happens when we get down to it. You'll see under different circumstances, different ones will be faster, different ones will be better. Right, let's open this file. And again, it's compressed. So if we have a look, there's our catalogues there. What I want to do is uncompress this folder, extract all, and we'll put this, let's copy that, browse, we'll just put that into documents actually, select the folder as it is. Take a little bit to, it's a very large file or set of files. These are, as I said, just the plates with all the star catalogues in them, or star calculations in them. So there you go. We go in there, a whole lot of them downloaded. It's an awful lot faster nowadays. When I originally downloaded these, it was off a dial-up system rather than fibre optic broadband. Makes an incredible difference. So let's close all that. While we're at it, let's get rid of this recycle bin. We don't need any of that. I think the next thing that we'll do is Stellarium. Download. Now this is from SoundForge, if I remember rightly. Oh, Softonic. So agree. Basic, that's good. Free download for Windows. I'm assuming that's the button. No, that's not the button. Oh, it is. It's just an advert, is it? There you go. Stellarium is downloading. It's downloading. Good. This is an amazing piece of software. I use this an awful lot. Wants to show me notifications? Absolutely not. I use this an awful lot for planning my astrophotography evenings. What I want, the targets that I want to go for. Just looking around the sky, seeing what's coming up at certain times, what's going down over the horizon at certain times, and from different views. I've got two piers, one upstairs on a balcony and one downstairs in the garden, and I can use it for looking at either of them, what views I've got, what's blocked by houses and hills around me, and what's not. It's absolutely brilliant. And it's free. Right, now that's downloaded, let's open it and install it. Do you want it to make changes to my device? Absolutely. Back to it. Accept the agreement. Put a desktop icon up. I'll be using this quite a lot. And install. We don't want to launch it right now. So close that. Actually, while we're at it, let's find N.I.N.A download. We'll download N.I.N.A at the same time. Why not? Let's do everything all in one go. Releases, latest stable release of N.I.N.A. This will be very good for us if we've got a second rig that we're going to be doing, or of course to use this. I mean, a lot of people use N.I.N.A. It's free software instead of Sequence Generator Pro. Now, I've got licenses for Sequence Generator. I've been using it for many, many years. I do use N.I.N.A, but not as much. But it's always good to have both of them anyway. If you're not willing to pay for a license for Sequence Generator, as I said, N.I.N.A is completely free, an incredibly powerful piece of software, worth having. There's definitely two camps, a camp of people who prefer Sequence Generator and a camp of people who prefer N.I.N.A. Never the twain shall usually meet. Both will defend to the death their particular pieces of software. For us, though, I'm going to put both of them down. So we're just at the end there, and there it is. Let's install it. I agree to licensing conditions. Again, N.I.N.A is another piece of software. It's been changed very often. So you need to keep a check and make sure that you've either got it automatically updating or update it quite regularly. Installation successfully completed. We won't launch it at the moment. Instead, what we'll do is go to our downloads. I'm going to clean up my downloads, get rid of all this, get rid of that, close this, empty my recycle bin, and we're ready. The next thing that we're going to do now is go through all the pieces of software and configure them to our particular system. Right, the first thing we're going to do, let's open up Sequence Generator Pro, and it'll check the license. It'll actually give us a 45-day period, first of all, I think, a trial version. Okay, so this is the main screen. What we want to do is... oh, why is it complaining at me? Because of this. bring this up. I think the first thing we need to do, we've got a trial version at the moment, 45 days remaining. So I'm going to go into help. We're going to activate SGPro. It's going to ask for a license key. Now I've got a license key which I'm going to put in. You won't be able to see it, unfortunately, because I'm keeping that off the video. And there we go, Sequence Generator Pro has been successfully activated. Click on that. A few things here. Focus lock, we don't need that. Flat box I'm not using. Haven't got an observatory. Environmental data, I can keep that on here. What we'll do is we can dock that over here. There we are. Image history, not really interested about. And this is the main screen for Sequence Generator Pro. If we go up to here, we can show sequencer, and this will be where we'll put details of what targets we want to put in, etc, etc. However, we've got to put a lot of information in here. First of all, information about the telescope and the setup that we're going to be using, get it pointing to drivers. As you can see in the equipment at the moment, there's absolutely nothing. We haven't got any directories of where we're saving things, file names or anything. So we'll need to mess around a little bit and get it sorted. So the first thing I'm going to do is go into tools and then options. Now in here we've got lots of different options about where we're going to put things, what we're going to do. If you follow mine to a degree, you'll get a good start. Obviously for your own equipment, for your own preferences, okay, change what I'm doing to whatever you want to sort out on your own computer. Okay, so the first thing I'm going to do down here, stretch levels, I'm going to do this to high. This is the stretch of images as they're being downloaded, so you'll be able to see your nebulas and everything rather than just a blank screen every time an image is downloaded. We've got the profiles directory. I'm not going to change that on here, I don't think. Default image directory. So let's browse this. I'm going to create a folder in here and I'm going to call it imaging in uppercase letters so I can see it nice and clearly, and select that folder. Later on, after this video, I'll probably change that to a Dropbox so that it downloads directly to a Dropbox, but for now that's fine. Now, custom key file pattern. Right, so as you can see from this key, there are a lot of variables you can put in and what those particular things do. I've picked out from a previous thing my particular pattern that I use, so I think we'll go through this. You can change this for each profile, or you can do it as a global thing. At the moment we're going to be doing it as a global thing. The reason being, once you've set up your file pattern, then it's easy to change later on, but you need one initially to do. So this is the file pattern that I currently use on my setup. So let's have a look at it. I've got percentage sign DT, okay, which is going to be the date, but we'll look down here and we should be able to see percentage DT down here, very small writing. This is date as in year, then month, date. Okay, so percentage DT will be saved. First of all, the file name will have the date on. Then it'll have a space, just a separator there, another space, and then percentage TN. If we have a look, TN, target name. Okay, so we'll have the date, then a separator, then target name. Then the slash here will be a directory, and then inside that we'll have target name again, then date, this time the other way around, and you'll see why in a minute. I've got here H814. If you're using, for instance, the 894C, you may want to put that in there. This is the camera that's being used. The nice thing about having a camera, putting the camera in the file name, is if you're using lots of different cameras, you'll be able to differentiate from your files which one is which. The next thing here is EL. That'll be exposure length. So here we go, percentage EL exposure length. Then percentage BI. If we have a look on here, BI is the binning. Now I only ever do 1:1 unless I'm focusing. Actually that's a lie, because on the guiding I tend to do 2x2 or 3x3, but normally your binning on your main files will be 1:1. Then percentage SU. So if we have a look on here at SU, we can see that's a suffix. We'll come back to that in a minute. And then percentage FN is the frame number. Okay, so let's see if I can show you this in action of what the directory would look like. So if we have a look here, this is from one of my Eagle observatories, and this shows some the last lot of data that I've actually got on here. This is my directory for downloading the images, and you can see we've got the date and then the name of the particular thing that target that I'm going for. And if we have a look on here, we can see we've got the date, then the separator, and then the target. If we go into there, because the slash here is for a directory, so let's go into the Ghost Nebula here, for instance, and we can now see it's the other way around. We've got the target name, percentage TN, target name. We've got an underscore and then DT, which is the date. So target name underscore DT, which is the date. Then I've got underscore H814 in this particular case down here. We've just changed this to 894 just to show you a different camera. Then if we go down here, underscore 600 seconds in this case. So EL is the length of the exposure. BI is the binning. We've got the binning here. SU, actually SU is filter, sorry, the suffix of the filter that I'm using. So we've got blue frames here, green frames here, red frames down here. We've got one lonely luminance frame in there. I did the Ghost Nebula over a couple of days, so we've got different frames which are here. And then the frame number. Okay, frame number 1 for most of this, 1.1, 1.-2. If we go on to this one, and let's have a look. Oh, we've actually got frame 2. So it's the frame number. It's just to differentiate each one of the files. We can do it by having the time after the date if we wanted to. Okay, but I've already got the time in here when the file was actually saved, so it seemed pointless to have the time in here as well. The date is useful, but not so much the time. This whole section here, which gives us which is variables telling us what the file name's going to look like, actually relates in the end to this. So I'm going to copy this as it is. I'm going to get rid of this here, move that out of the way, and down here in our custom file pattern I'm going to paste that in. If you have wanted any other details within the file name, then obviously use this key for adding further variables into it to change the file pattern, or take ones away that you don't think they'll be used, like the camera, for instance. If you're only ever using one camera, then that's fine, take that away. So let's close this. Okay, so actually what I'm going to do, I'm going to change this profiles directory. I'm going to use exactly the same directory as I'm using for the imaging. So we'll put that in as well, so everything's together. Let's go on to sequence options. Number of events for targets, I would normally have this a little bit higher for me, so I'm going to put 12 in. You'll see why in a bit. You'll have to apologies, my dogs are playing right beside my feet at the moment. I'm going to rotate through events. Don't have any delays. On failure, attempt to move to next target. Restart sequence when conditions are safe. We'll certainly have that one on. Show option to skip gear shutdown on safe for 30 seconds. Capture calibration frames, no. Attempt to recover the sequence, we will do that. Try and recover every 2 minutes for 90 minutes. That's absolutely fine. Now that's if clouds start coming over or anything, actually it won't allow 2, it'll allow 5 minutes. So attempt recovery every 5 minutes for a total of 90 minutes. Now pop-up filters, show pop-up notifications for levels. No, we'll do that. Sequence actions, clear sequence suffix, drop down list. Yeah, we don't need to worry about that. Themes, for if you want to change the theme of your the software. So I could have a dark theme if I wanted to, or a light theme. I'm just going to keep that as standard. And external apps, I'm not using, I am using PhD. So let's browse for our PhD 2. Which will be in here somewhere. It's not there. So PHT2 guiding. We just need to select the folder, I think. Locate the folder where it is. Pinpoint I'm not using. That's another one I could download. Plate solver. There's a plate solver there. Where's those files? I think that's already installed with it. So, okay, must be restarted to change our profiles. So let's restart the software and carry on to the next bit. Okay, so we're currently using 64-bit of version of SGPro, exactly the same as the 32-bit version. Don't need to worry about that, don't show that again. Okay, obviously if you're using a 32-bit Windows computer, then only download the 32-bit version. Okay, that won't start up again. Right, just before we go into the equipment profiles, let's look at one other thing actually. I just remembered the user profile manager. This is in tools. And if we go in here, we can put profiles of the site location. So what I'm going to do is, first of all, use profile as default for new sequences. Observer name, I'll just put Fred here. Site name, Sunnybank Observatory. Elevation, I guess it's about 35 meters. The site latitude 50. I won't put the rest in, just to we'll have it as 00 for now. And site longitude. You can put the site horizon in there. That's the your basic horizon, but really you've got to be fairly open. I've got houses and things around me. I'm not going to put that in. Okay, and we'll save that. You must specify a profile name before you can save. Sorry, let's do that. Put it up here. Put Fred up there as well. And there you go. From now on, Fred will be our profile, and that will be put into the fits header as well. So all the information will be there. Okay. And now the bit that a lot of people trip up on, we're going to have a look at the equipment profiles. Now, the profiles are, this is blank obviously. I have got quite a lot of profiles on my system that I actually use. This is where you put all the information of different telescopes, different camera options that you use, etc. So that when you want to use on a particular night a certain setup, you can put that setup on your pier, or if it's permanent, have it in your observatory or whatever, and choose just a profile, and it'll have all the information already populated into it, and you can then literally just start imaging. So we're going to create a new profile. So click a profile or type a new name here. And what I'll do is I've got an FS78 Takahashi, which we'll use an example here. And I've got an H694 Starlight Express camera. It's a color camera, so I'll put that in there. And that's all I need to do. I use this profile as default for new sequences, and I will save it, so it's now there. In here we put our details. Okay, whatever details we need as we go along. It's best to do this nice and methodically so that you don't miss any parts out. So we've got the cooler here, cool down to -40. Now this -40 degrees Celsius isn't necessarily the exact temperature that my camera is going to go down to, but it will keep the cooler on until it goes down to -40. Actually, my camera, the Starlight Express H694, is 40 degrees below ambient. Now, in this particular case, I'm assuming ambient is 0. It's very unlikely to be 0. I'm down in Cornwall, it's usually quite warm. But if I put -40, it just means that it'll keep on trying to cool the camera as time goes on. So as the night gets cooler, it will cool down the camera even more, and the -40 behind ambient will actually mean the camera will be colder. Settings and specs. Now I've got my camera on the Starlight Express at an angle of 270. Actually, I haven't said which camera. Let's put on the camera 694. There you go, and it'll auto populate some bits inside here. I can click on settings and let's see, has it brought anything up? I keep this as default. This is the normal camera setup settings for ASCOM. Don't need to change any of that, so okay to there. The angle of the camera I've got at 270 degrees. Now that may seem a bit of a funny angle. It all started off when I first got the camera as having it so all the writing on the camera was at my horizon. It was level. I did find over I have found over the years that most targets fit into a 270 angle really nicely, whether that's M42, the Great Orion Nebula, we've got the Heart Nebula, the Veil Nebula, everything seems to fit into it, except 104. 104 is the Sombrero Galaxy. That's tilted 90 degrees, but I can change that angle, whatever. But inside here, I'll put the angle so that when I'm using my framing and mosaic wizard, it'll show me accurately how that framing is going to be. And obviously, on a particular night of imaging, I will turn the camera to whatever I really need. The scale, I'm going to set a 1.21, which is with the flattener and everything on. That's my pixel scale on there. So 1.21 degrees a pixel at 1:1. Readout noise, I'm going to put as 4.0. Actually, it's less than that, but that'll do. And then I've got to put in the pixels for the camera, how many my horizontal width of the pixels is there, and the amount of pixels height. As you can see, this is quite an old camera now, but it's done me very, very well, and I still use it all the time. I still use CCDs more than CMOS. It's a habit forming thing. I don't like change, and at the moment I haven't really upgraded to CMOS yet. I'd suggest if you're buying a new camera, you would be looking at the CMOS ones, I'm sure. Download times, these are the maximum download times. Now it usually takes a second, 2 seconds to download max, but if I put 20 seconds in there, it'll actually allow it to wait for that time and won't come up with an error beforehand. So I'll just put in some extra values here. The Bayer pattern is RGGB, that looks correct. haven't got an offset. So that's the camera side of it sorted. As you see, these tabs across the top: camera, filters, focus, etc. So we'll just go over onto the next one. Now this is actually a color camera, but I have still got a filter wheel. So let's see if it's brought up my filter wheel. It hasn't. Now this is quite fortuitous because we've actually shown what happens if you haven't got something preloaded into your ASCOM. You haven't got a driver. So what we need to do is put the driver for the filter wheel in. What I'm going to do is just go OK here and save this profile. I'm actually going to close this sequence generator. Do you want to save the sequence? No, we haven't actually got a sequence. And I'm going to see if I can find the driver for the filter wheel. So Starlight Express filter wheel driver. And obviously the camera driver doesn't deal with it. So resources, Starlight Express. And obviously if it's not a Starlight Express filter wheel you've got, it's something else, then you would go down and you would search for that. So SX filter wheel, ASCOM driver. Perfect. Let's have that. Open the file. There it is. And run it. I accept the agreement. Install. We don't need to view the README, and finish. That's all there is to it. So now, actually, is there any others that I need here? No. So close that down. I'm going to restart my sequence generator. As you can see now, I've got a proper license. Lost connection to Powerbox. That's because I haven't got a Powerbox added to it at the moment. There's an update available. The wise among you will notice this is a couple of days later. This video I've had to write over a few days. Anyway, tools, equipment profile manager. Let's go back to our FS78 with H694C. If we now go into, and you can see this is all populated, it'll bring up the last one anyway. Now we've got our filter wheels, there's no filter wheel, and we'll choose Starlight Express filter wheel. Filter change delay, you always want a little bit of a delay, so let's have 5 and set filters. Right, so 1, 2, 3, 4, 5 filters. So switch those on first of all, and we'll have a look, see what we've got. So the first one I know is hydrogen alpha. Autofocus expose. So how long would we have an exposure for HA? I'm going to start off with 30 seconds. Focus with filters, don't need to do that. Focus points, we'll deal with that at a later stage. The next one will be, oh actually I've got HA first of all. The first one's luminance. Sorry, so luminance, which is just the normal RGB colour, in which case we don't need anything like that. I'm just going to have 8 seconds. Then we've got HA, and we'll put that on as 30 seconds. Then if I remember rightly, it's oxygen. 1, 2, 3. Ionized oxygen, I'll do that as 30 seconds as well. And then sulfur, and again 30 seconds on there. And I've actually got hydrogen beta one in that filter wheel. Bought it many years ago. I haven't used it hardly at all, but it's there. And we'll do OK. Set no filter flat stay, so I'm not going to do that at the moment. Let's go to the next one. Focus. Now I have got a focuser on here. The focuser is a Pegasus focuser. So let's have a look and see what we've got here. ASCOM Pegasus focuser. Have a look at the settings. Everything nice and easy there. I've only got one focuser on here. Okay, actually that's for the ultimate power box we've got on there. Now on this particular one, I'm not using that. I'm using a different Pegasus focuser. Let's just have a look. Driver with the ultimate power box. Keep this open. It'll probably work, but I'm going to put in the focus cube. So that's another one that I need to put in there. So I'm going to go OK, save it. Here we go again. I'm going to close this. This happens an awful lot when you're setting up Astro equipment. I'm sure you'll realise. So Pegasus focus cube ASCOM driver. Pegasus Astro. Right, Focus Cube 2 Universal. I believe that's similar. I've got an older version of it, but it should have the same drivers. High resolution, lots of information here, but we want the software. ASCOM Indie support. Software. Pegasus Astro Unity platform is our new all-round application. So current and future products in one roof. So actually that driver is probably okay. Let's have a little look. Software. Unity platform. Obsolete software. Please use Unity. ASCOM focus driver. Click on that. Feel like a detective having to find various bits of software and information when doing this. Click install. Don't need to do the readme. And again, we'll close that. I'm going to start off my sequence generator again. That should all be in and running. Quick drink of my coffee while I'm waiting for it. Tools, equipment profile, open up this one again. We're on the focus. Let's have a look in here. Here we go. Pegasus Astro focus controller. So settings, device ID. Well, I haven't got one on there at the moment, so we'll just do auto. Backlash compensation, that's when we're calibrating, we'll need to put that in, but we certainly don't need to do anything at the moment. Start from position, everything else we'll just leave as it is. It's a stepper motor design, so okay. Now we're going to have, we've got to put in some step sizes and things here. So for fine focus, I'm going to put 15. For coarse focus, I'm going to put 100. These are just my starting ones at the moment. I've got the focus cube back to front, so I'm going to put reverse direction in there. So it'll it's actually going backwards as far as the software is concerned. Focus reminder. I don't really need any focus reminders, so we won't need to worry about that. If we go on to use autofocus, which is what we are going to be doing, let's go into this and set it. So we're going to use half flux radius. Yes, we're going to focus on filter change. We'll focus at the start of the sequence, but not on resume. And we'll focus we won't do every frame because we don't know how often we're going to, how long our exposures are going to be. So I think we'll do an autofocus every 60 minutes. Okay, so with the temperature changes and things, it'll pick that up. Now there is actually a temperature sensor on the focus cube on my particular equipment, but we won't deal with that at the moment because again, it's part of the calibration process that we'll need to do that. I'll also do autofocus after automatic centering, so if it recenters somewhere along the line, it'll from one object to another, it will do another autofocus. If we put on here our focus time, so for OSC, I'm just going to put 5 seconds there for exposure. Put exposure time for filters, well, we've already got that in, so we've already shown from when we were putting in our filter wheel details that we're using 30 seconds at the moment. We'll be able to drop that down. Always start off larger and come down a little bit smaller. I'm going to put my autofocus data points at 8. And my binning, I will always do 2x2. Of course, on a color camera, that means it will come out black and white, but it's fine. The step size here, I'm going to do 100. Autofocus, auto dialogue. Actually, 100 seems a bit much. I'm gonna step that down to 80 for now. That's still a fine focus on this particular focuser. Auto close delay. I don't want to wait 30 seconds for it to wait to go. We'll crop and focus by crop the focus frame by 10%, 15%. So it's only looking at the stars in the center of the frame, so that if you've got any aberrations on around the side of the frame, it won't try and autofocus on those. And I think I'm going to save all my autofocus details, so every time it does an autofocus, it will save that information so I can look back on it. So I'll just start up do a directory called focus, okay, and we'll use that. That way I can set it off to do lots of focusing if I want to, and then afterwards check on it, which would be very good for working out my filter offsets and things like that. That all looks perfect. Not doing temperature compensate at the moment. Frame and focus is the next thing I want to do, so I'm going to do a 2x2 and an exposure of 5 seconds. This is for when it's trying to find objects in the sky and it's about to do a plate solving, so we'll do that. Okay, that's perfect. Now we'll go over to the telescope itself, where we've got to give information about the telescope. So we'll park the telescope when a sequence completes. We will auto meridian flip, and that should be fairly self-explanatory. If you're using a German equatorial mount, then it'll flip the mount. Minutes past the meridian to flip, and we'll have 5 minutes there. We can have wait for the meridian. If you put that on, then if an exposure is about to happen before a meridian flip and it realizes there's not enough time, it'll actually wait for the meridian. I don't think we'll need to do that. We can go past the meridian quite happily on mine, quite far. So pause before meridian flip, no. Alter center after a meridian flip, yes. A delay for the meridian flip, that's set at 30. I'm just going to leave that as it is. It's fine. Okay, is there anything else I want to change here? Yeah, mount settling time, I'm just going to put 5. I will be using different mounts sometimes on here, so although I'm using my astrophysics mount most of the time, I have got an EQ5, which is a much smaller wobbly mount, and I do tend to use that quite a lot on this one. So settling time of 5. We want the scope focal length, which is about 630. It'll pick it up exactly later. The aperture of it, well, is 78 millimeters, so 78 millimeters. Telescope, there's nothing there that I need to worry about, but I can put the mount in. Astrophysics mount, settings, just going to leave those. Oh no, here we go. So mine is a 900 go-to. It's using CP2, CP3, sorry. COM port, it'll pick up the COM port for me later on when I'm calibrating. I haven't got the equipment actually installed on it at the moment. The telescope focal length, I'm just going to leave that, don't need to worry about it. Let's have a look, is there another one here? I'm going to turn off the periodic error correction. Now the reason for this is quite simply I don't want the auto guider having to fight periodic correction at any time. Nothing else needed there. The sight will actually automatically come up when it connects to the 900 GTO, so I don't need to put anything else in there. Your mount will be different, but that's my one sorted. Next, we'll go on to PlateSolve. PlateSolve's fairly easy. I want to use PlateSolve 2 as my general one. If we have a look at the things here, we want to bin it 2x2, make it nice and bright. We'll have a 20-second exposure. We can bring these down during calibrating, but we'll start off at the highest values. Attempt to center 6 times until an error of 50 is a bit small. Let's have 70. Let's have 100 pixels. So that's the center of the whatever you're plate solving. It can be out by 100 pixels and it'll be absolutely fine. 100 pixels is quite a lot. Sorry, it's quite small in the field of view. So 100 is absolutely fine. Don't need to change that. Use filter. I will use. No, I won't. Yes, I will. I'll use the luminance filter. That's right. If PlateSolve 2 can't solve it, then we'll use a different one. In this case, we'll use Astrometry Net. It's already set up there, so that's fine. Astronomy Net is an online plate solving site, and it's very, very good. So just in case. Now we'll go into auto guiding. Auto guiding is nice and easy. We're going to use PhD 2. We're going to do a small dither every 3 frames and settle for half a second. Yeah, that's fine. The settings, by the way, for PhD 2 guiding, it's refreshing. We haven't got a profile, so later on when we've created a profile, we'll actually have to put that in there. I'll just put my equipment for now, which is the standard one, so that's the one I'll edit. Disconnect gear from PhD when the sequence is done. Well, it's going to be parking, so yes, we'll do that. Don't need to change any other options, that's fine. Switches, haven't really got any switches at the moment until I put my flat panel on. So I'm just going to leave that at the moment. We haven't got anything installed on there. If you've got a rotator or flat box, a safety monitor. I've got a safety monitor on one of my kits downstairs, but not on this. You would put that into there, and basically that's it. Okay, save that, and we have now got a complete equipment profile. Okay, now we've done that, let's get on to the next bit, which will be setting up PhD. Now I do notice there's a Windows Defender thing here for PhD 2, so I'm just going to allow access to that everything. This is my PhD 2 window here, and we need to set up our profile. I'm not going to do it from there. I'm just going to have everything as standard. And click on connect. It looks like camera mount. Setup wizard can help you with this. I don't want to use the setup wizard. So I'm going to, the camera in this particular case would be the Starlight Express Lodestar. So pick that up. We can connect to that once I've connected all my equipment up, but at the moment this is just blank. Astrophysics mount, put that on there. I haven't got any more equipment, so we won't worry about that. Go on to settings. Here's the settings for it. Language, English please. Automatically check for updates. Yep, we've got a file location for PhD2. Enable diagnostics logging, yes. When relative error, when absolute error. Nope, that's fine. Do the settings random, that's fine. We'll go onto the camera. We're going to use lots of noise reduction, so I'm going to use 3x3 median, auto exposure, yep, between 1 and 5 seconds, target S&I, yep, that's fine. Camera is not connected, additional camera properties will be able to use afterwards, yep. Disconnect noise after, right, pixel size. So I'm going to need to look up the size, so let's have a look. We go Starlight Express load star 2 specs, and if we have a look at here, we've got 8.2 by 8.4, so I'll just put 8.2 on there. Oops, close the whole thing, didn't mean to do that. So that goes down 8.2. I won't use subframes at the moment, I will do later on. So guiding regions, use multiple stars, that's absolutely fine. Basically going to keep this standard. Calibration, focal length 630. Auto restore calibration, so after it's done a calibration it'll automatically restore that for us, that's fine. Calibration steps is fine. Enable go, yeah. Algorithms, I'll keep these as standard at the moment. I will probably change to no, I don't want predictive PEC, so I'll probably change this resist switch at a later stage, but we'll see how the auto guiding goes. Okay, you must restart PhD2 to take effect, and we'll do that. And there we are, we're ready to go. So once we've connected our equipment, we'll be able to see what's happening there. So close that now, don't need that anymore. The main sequence SGPro is done. N.I.N.A, of course, almost exactly the same. Everything's laid out very different on N.I.N.A. I won't go through N.I.N.A on this particular run at the moment, but if you've got all your information in your equipment profile up here for SGPro, then use the same type of software, sorry, the same type of information, or the same information in N.I.N.A's equipment profile, and there's many videos on that. You'll be fine. So I think the next thing that we will do is we'll close this and we'll go into Stellarium and we'll update Stellarium. Now the reason that we're going to be doing this is so that we can put in the same kind of information, needs a lot less in Stellarium. We'll be able to frame and focus in there a little bit as well. So if we can set all this up in one go now while it's light, then by the time it gets dark and we actually want to do some imaging, most of our work will be done for us. First load with Stellarium is going to take a little while.
2 hours later.
Okay, when you open up Stellarium, this is kind of what you'll see. This is the sky. We can We can have a look at certain bits. We can even search for them over here. Now, as you can see, this I've already started using my Stellarium on here offline for a little bit, just to get it all set up. But you'll set it up your own way. M42, the Great Orion Nebula. This is going to be one of the ones that we'll image, especially as winter's coming up at the moment. Up the top here, you'll see a little tools thing here. Normally it's on general and gives you some options that you can set. You can set whereabouts you are, your what views you've got. We can also go into here and put in different telescopes. I've actually sat here and put a couple of my telescopes in. The Takahashi FS78, which is what we've just been setting up. This gives us all the details here. 80mm diameter. Okay, so it's 78. It's not a lot different on there. Horizontal flip. Yeah. I've also put in details of some of my cameras, including the SX694C that we've been setting up, with details of the off-axis guider. Now, a lot of this you'll need to go and find information on to be able to pick it up. Just look up your camera and the specs for that camera, and it'll tell you, and literally just go through here and put in all those information. Lenses I've just left as Barlow 2, Barlow 3 and a focal reducer. You can also put in your eyepieces. These are ones that come with Stellarium already set up, so we don't need to worry about those. And that's it. The idea of putting all your information in is that any time you find a target, like we've just found M42 here, I can now click on this one and it will show me my framing of M42 based on what it'll actually look like. So this frame here is the capture frame of the main camera, and this particular one here is my guider, so it'll actually show me what guide stars I can use. In this case, this one here would be quite a good one. If we pick another object, now at the moment these objects are very low in the sky, so that's why the framing's looking terrible here. But if I fast forward a little bit until tonight, so let's fast forward the time a little bit. It's lunchtime at the moment. Here we go. Actually a little bit later than that. It's 9 o'clock tonight. Let's come up until it's fairly close to the there you go, to the south. All right, now we can have a look in here. There's our framing, which is going to be quite nice. Do you remember I said that 270 degrees was fine for me? Well, that shows what 270 degrees will look like on that particular target. We can find other targets. Let's try M45, which will be up beforehand. And nice bit of framing there for the Pleiades. And as I did say, M104 is one that's completely opposite. So if we have a look at that, you see the framing is actually the wrong way around for that. But on the most case, 270 degrees works for me. All right. The other thing that we can do here that I've already set up is my location. I have put in here a photograph. It's a 360 view photograph of where I live in my landscape. So let's show that a little bit. And this is my garden view, which is nice. You can see it's quite dark, but then it's nighttime. And this is where my pier is in the garden. So I can see at any one time, as time goes on, where something is going to be in the sky. So if I go on here, you can see that Orion will be rising there up above this house here, across over the sea, and it'll set down in the west down here at about 6 o'clock in the morning. Okay, so I've got quite a bit of imaging time on that one if I want. I can go back a little bit further and see when there's other objects in the sky. If I want to do the Pleiades, for instance, I would have those. Now I have got a telegraph pole there. I don't know how well that's coming up and showing. So but the Pleiades goes above that pretty well. So let's find it. There's the Pleiades there, and it's above there, so I can actually use, if I was imaging the Pleiades, let's see what the first time is. Well, I can start imaging it. Will be about there. So I can start imaging at 10 to 9 o'clock sort of time, right the way through till 6 o'clock, so I can get a really good night of imaging the Pleiades if I wanted to. And if I zoom in on the Pleiades, let's do M45 again. There it is. I can see how it will be framed if I want, and I want to frame it based on that star there. Perfect. So that'll be a really nice image with a good 6, 7, 8, 9 hours of imaging on the Pleiades if I wanted. Now we can just look around as well and see what other things are available. There's a nice dark nebula here. Oops, missed it. Let's go back again. Basically click a star and press space and it'll center that for you. We've got a nice dark nebula here. That would be a very good one for imaging as well. That's an RGB one, so we don't need to use narrowband or anything, which would be really good. So as you can see, you can look around the sky, pick different times and see where things are, which is really nice. If you want to spend time doing a background, I'll have a video on that as well, so you'll be able to see for yourself where from a particular location where things are, and plan your nights a little bit earlier on. So you can plan your nights during the day, and then think about what you're going to image, so you'll have everything ready for when the night time comes. You can see I can't do an awful lot of this nebula with this this telescope. I would use a different telescope for that. So, whoops, so I missed it again. Why I did that, I don't know. So let's go back to it. Let's center that by clicking on the star, pressing space. So my 60 CB is still not good enough there, so I may need to change my camera completely to get a really nice wide field if I wanted to pick the whole thing. And in fact, even with my 60 CB, I can't get all of it in, so I might want to use my ASCOM there. Actually, if I use a different camera on the ASCOM, I could, there you go. I get some really nice framing. If I wanted that particular nebula and I want to get the whole of it, then using my ASI 183 GT with my ASCOM would give me an absolutely beautiful view. Okay, so that's Stellarium. If you want to update Stellarium, which is always a good idea, go into the tools section, and I don't think I've got any updates showing on here. Oh, that's just the oculars thing. So let's go configuration, tools down here, plugin scripts. We should have, if there's anything extra to download, it'll usually tell you, oh, I've still got a catalogue actually to get, so I can click on that and that will now update my catalogues. There's 9 catalogues in all, so if you spend time sitting down downloading them, they'll update all your stars, all your nebulas and everything in the sky, make it nice and easy for you. So that's Stellarium done. I know I didn't go right the way through the setup on here, but it is quite long and laborious. I wanted to put in the details of my landscapes, my cameras, my telescopes, but it's all very easy to do. You've got a configuration down here to configure the whole software. You've got Oculus, which is in the plugins. So in the plugins here, here's Oculus, and you can press the configure there if you don't see it up the top already. If you want to do landscapes, then down here in Sky and Viewing Options window, you've got your landscapes, and we can change our landscapes as we want here. So now I'm in my balcony, and as you can see, my pier on my balcony gives a different view. Okay, and I can see the Pleiades isn't even up here yet, and so if I've got a telescope on there, I've got a different view of what I can get to see. So that's basically Stellarium sorted. So let's close that down and see what else we need to do. So now we've seen that in Stellarium a couple of objects that we'd like to photograph, and realised that our telescope setup will be fine for being able to image them. Let's go back into Sequence Generator Pro again, which is the main software that I'll be using for this. Now, with the Sequence Generator Pro, I'll also be using my power box. So hold on, Plate Solver 2 solver is selected, but its catalog references are broken. Okay, so we're going to need to do that in a minute. Oh, there's the power box thing. So let's pick up the Pegasus power box. Ultimate power box. Run that a second. So this will decide what outputs are actually going to be switched on and off, what our dew heaters etc. are going to be. Obviously I've got to connect this as well. Focus we're not going to be dealing with. The power graphs are always useful to make sure that something's not taking too much power in relation to whether we're using batteries or whatever, any other settings. So that'll be done when I've actually got all my equipment connected and testing out, which I'll do dry during the day. At a night time, on a nice clear night, the last thing you want to do is be messing around with settings too much. Now I will need to calibrate everything, but get as much work done beforehand as possible. It would be great. Now we do need to have a look at this plate solving 2 as well, and the best way of doing that is I'm going to run it. So if we go on to this PC, drive C, let's see if we can find it. It was in documents, if I remember rightly, plate solve 2. There it is. Let's run it a minute and set it up. So it's going to be looking for its directories. So configure directories, here we go. So in here we've got the APM directory. It can't pick that up, so let's see if we can find it for it. Drive C, it won't be in program files, it'll be in users. I don't know why I'm called match there, but let's have a look. Oh, there's the UCA3, so actually that's the one we'll do first. So cancel that, let's do this one because we know where it is. So users, match, documents, and click that. There you go, status is okay. So that's that one done. And now we need to have the plate solve 2, sorry, the plate solve 2, the APM ones. So I believe they are in program files. No. Starry Ridge, APM. Let's have a look. Status okay. Perfect. So we'll open up the actual sequencer. This is what we'll see each time when we want to do an imaging session. As you can see, it's already put up the details here of the user profile and all the equipment that I've got. Once I've got the equipment connected, I can first of all go into the device settings just to make sure that it sees it. Once it does, press the power button, that'll switch it all on for us and we can connect straight to it. We've got details of our targets down here, and here this is the list of the targets that we'll decide, and this is what exposures etc will do for it. Because we put rotate through events in the event order, that'll show up here. There's no delays before or afterwards, which is fine. And we've got run sequence down here, details of the elapsed time, what target we're on. We've got a lot of information in a little window here. These outside windows you don't tend to use so much, but once you get used to the software, you'll tend to use that as a reference point on an awful lot of it. One thing that I haven't got there is a toolbar for focusing. So at a later stage I'll put a tool shortcut in there for focusing and put that over, but oh no, here we go, flame of focus is already there actually, so that's useful as well. So we've got just about everything that we need. Close this and we'll go up and frame our let's choose M45, the Pleiades, which we were using before. So from tools, go to frame in mosaic wizard. I'm going to type in here M45 and fetch. Now you see the field of view here is shown as 4 at the moment, which is quite a wide field of view considering we're only using about 1.6 of it, but you'll see with the framing why it's done like that. It's already picked up the information when I pressed fetch from M45 and put that on there. So here we go, nice little picture. If we draw a triangle here of any size, you'll see that that's our frame, and you'll see that it matches what we had in Stellarium nicely. So we can move this around by pressing the 1 and decide whereabouts it is. If we wanted, we could do a mosaic. So let's put that on here. Down here is for the mosaic, and we can choose how many frames we want to do as a mosaic. So if the object is really large and you haven't got different telescopes or a reducer, you can mosaic the patterns, your target, quite happily. But let's go down, make it nice and easy at the moment. We'll just have a single one here. Put it in there. Decide our exact framing of how we want it. If the box is too small in there, we've got a field of view of 4, which is a little bit small. So I'm going to put 2.5 and I'm going to fetch again. Now what that'll do is refetch and re-put on the screen the new size that we want. There it is. Just put a box on there and we can now frame a little bit easier. And of course you can change this field of view to whatever you want, but if you change it past sort of 10, it starts taking quite a lot of time to be able to pick up all the data. That looks absolutely perfect. I want to image M45 with that framing exactly. I've got my 270 rotate on, everything's perfect, so I'm going to create that sequence and it'll start doing it automatically for us. Here's the name. Append the target to the sequence. Yep, that's fine. We want to slew and center on the location. We don't want to rotate. I haven't got a rotator, so we don't need to worry about the camera angle. Associate working image with sequence, we don't need to worry about that, so let's OK. It'll say your sequence will have targets created, etc, etc. Just do OK, and hey presto, oh, we got a new, let's close that. Hey presto, on M45, okay, we won't be using target 1 because that's an empty one just to show. Target M45, click on that, and we've now got that ready to start imaging. If I want to do luminance, I want to run suffix, I'm just going to put LUM for luminance, or I can do, because it's a one-shot color camera, I might just do OSC there. We'll do 5-minute exposures and we'll do 20 of them. I could also, this isn't really the right target for it, but if I wanted to, I could do an HA, and it will change the filter for me automatically if I wanted to. HA, seriously, don't do HA on M45, but there is the option for it. Let's do a 10-minute exposure on there, and we'll do, instead of having to write all these down all the time, from the top one here, if you're on the top one, you can double click repeat, and it'll just put right the way down exactly the same. We can do that on any one. If I do exposure of 5 minutes, it'll just expose 5 minutes all the way down. We can add new events, okay, so that you can choose as many events as you wanted. All right, we only need 2. In fact, if I turn that off, we're only going to be running 1. So you can set up one of these if you wanted and move it to different targets. So now we've done that, for instance, if I pick up another target, let's close that and go into our framing and mosaic wizard again, and we'll pick up M42. This was another one we looked at in Stellarium just a minute ago. You can see it's picked up the coordinates for it. It's left our field of view at 2.5 because that was the last field of view we used. There it is. We'll frame it up to how we would want it. I'm going to go create sequence. M42, that's fine. Slew and then center, yep, already sorted. Okay. And we can see now that we've got M45 there and M42 afterwards. M45, we've got a couple of runtime exposures and things put into here. We want the same thing for M42, so click on M42. I'm going to right hand mouse click M42, and it will say copy events from, and we'll choose M45. It's now going to copy those events across. So now I'll put on my HA. So what will happen is M45, it'll try and take 20 exposures in RGB. Okay, because it's a one-shot color camera. It won't take any HA, but now if we go to M42, straight after it's done the M45s, it will do M42 and it will work on those. The other thing we can do here, if we go back onto M45 here, we can click these wheels here at the side and do some more get some more information. So we know that M45 doesn't come up until about 8 o'clock at night. Okay, so 8 is 2000 hours. Okay, so we'll put that in there, 2059, 2000. So it'll start at 2000 when it's gone past the house next door, because I'm using my back, the pier in the back garden. I'm going to end, now do you remember at 9 o'clock we had M42 came up. In fact, I think it was a little bit later than that. So let's just do 10 o'clock for M42. So I'm going to start doing M45 at 8 o'clock. I'm going to finish at 10 o'clock. Doesn't matter how many frames it's done, but that's when it's going to finish. Okay. And then we've got M42. If we click on that, we can tell M42 to finish at 6 o'clock in the morning. 06, or choose whatever time it's going to be, end at that time. We don't need to put a start on because the start will be automatic. Okay, we've got a whole night of imaging right there and then, and we'll get a load of images of M45, as many as we can out of this 20. If you wanted to change this 20 to 100, you can do. If it only manages to do 20, it will stop at 10 o'clock and we'll go on to M42 anyway. We've already said before that if it can't find the target, or something's wrong, whether the cloud goes over or whatever, we've already told it before in our settings that we will retry again for 90 minutes afterwards. So even if M42 is behind the roof, it will keep on trying for about 90 minutes until it appears, and then start imaging that. And there you go. On M42 it'll be doing the RGB and it'll be doing the HA. It will be changing on this particular one, it will be changing the filter to HA. So we'll do an RGB, then the next one will be HA. Of course, it'll do a focus routine on there, and then it will go back onto here to OSC and then HA again, doing a focus routine every single time. If we want to change that, we can go into Tools, Equipment Profile Manager, go on to our focus, your autofocus here, and make sure I've got autofocus on filter change. I can take that off. The other way of doing it, and we'll save that. Once we've saved something, show the sequencer, we want to apply that new profile to the sequence, so we'll apply it. So now it's updated. Forget the power box at the moment, we haven't got that connected. And now when we rotate through the events, it will focus once every hour, which is what we set up in the autofocus, rather than every time that it goes through here. One of the tricks you can do is change this in such a way. Let's change this to 300 there. I'll change that to I'll leave that actually. I can add a couple more here, so we're doing 3 luminance, okay, which is our RGB obviously, because we're using a one-shot color camera, and then we'll do, let's say, 2 HAs, and this suffix, by the way, goes on to the this is the actual filter that's used when it says filter, but the suffix there is what will be put on the file name for us, and we'll have that as 10 minutes for the 2 HAs. So now if we rotate through the events, because if we had a finish entire list first, then it will try and do 100 of the luminance before it then goes on to the next one, etc. But in this particular case, with rotate through events, it'll do a color one for 5 minutes, another color one for 5 minutes, another color one for 5 minutes. Then it will change to HA. We can get it so that it automatically focuses the telescope when it changes the filter. Then it'll do a 10-minute one there. Then it'll do a 10-minute one there, and then it'll rotate back up to the top. In this case, if we've got it focusing on every filter change, it will refocus and then do these. And you can add lots of these, so you could have 10 of the luminance and then 2 of the HA, or 10 of the luminance, 10 of the HA, etc. Just add on as many as you want. And by rotating through the events here, especially if you've got mono cameras, you're wanting to do LRGB, you may want to do this so that you pick up every single filter during your night time. It'll take a little bit longer because you are doing a focus routine between changing every filter, but at least you get a chance to get some reds, some greens, some blues, rather than maybe just have loads and loads of reds. Okay, once we've done this, I'm going to save this as my winter sequence, winter 23. It's a sequence generator file. I'm just going to save that, and now forevermore I will have M45 and M42 unless I delete them. And next year, for instance, I mean, I can keep on adding to this if I want to, and then come back to M45, M42 next year, or next week, or next month. Okay, I think that pretty much shows you everything that you need to know. When you're ready, you'll run the sequence. It'll come up with a couple of things about your camera cooling, whether you want to continue. This obviously is after you've got your equipment switched on. It'll then run PhD2, and it will lock onto a star and make sure PhD2 is running, and then it will move the telescope mount to the object, the target you've got on your list. In this particular case, M45 will be the first one. It will autofocus, change the filter and autofocus on that particular one. Then it will set PhD2 to actually guide on a guide star which is next to it. Once the guiding is settled, then it will start the frames as per the list you've got down here. And it will keep on doing that in this particular case until M42 finishes, at 6 o'clock in the morning, or unless something else goes wrong. You will need to do some tweaking, some messing around to be able to get everything working, but I hope this video shows you how easy it is to get a PC, whether this is a laptop you've already got or a PC you've already got, or whether you buy a fanless PC in this particular case to put on my telescope setup, or even if you've got something like the Primalucci Eagle, you can then set it up with this particular software. If you use N.I.N.A, N.I.N.A works in a very, very similar way. It's got a lot of videos that you can look on YouTube about using N.I.N.A. I've got a couple coming out about using N.I.N.A as well. I do use N.I.N.A as well as SGPro, and with it, I think you'll be able to automate your astrophotography like I do. I literally just write down a list of what I want in an evening, switch everything on, set everything going, and then promptly go to bed. Wake up in the morning, the telescope's already parked itself, it's already saved all my images. Hey presto, I'm done. Okay, there we have it. We've now got a computer with all of the equipment or software on that I would normally use. A lot of it's already set up, ready for us. What I need to do now is attach this to a telescope, take it out, and spend a couple of hours calibrating everything to make sure that everything's okay. And then I can use that setup for imaging right the way through the winter. We've had a nasty couple of years really, but certainly the summer for astrophotography. So I haven't done hardly any at all. I'm hoping this winter I'll get some clear skies, and this time I'll use my new rig with the Intel NUC on it, and we'll have a little bit of fun and hopefully get some pretty pictures. Anyway, till next time, bye for now.